So this is a video tutorial about how to do the Path of the Sun lab. So as we know, here in New York State, we see the sun at different positions in the sky throughout the year. In the summertime, it's actually obviously higher in the sky. In the wintertime, it's lower, and anywhere in between, depending on the season. The materials you'll need for this lab are a plastic globe, an azimuth sheet, a protractor, a dry erase marker, and the lab will be found on Classroom. So the first thing we need to do is get down this concept of azimuth. Well, azimuth is a degree on the horizon, starting in the north at 0 and moving east to 90, south to 180, west to 270, and then back at 360 again in north. So north can either be 360 or 0 depending on which way you're going, and anywhere in between. You're going to be using your protractor to find and label positions of sunrise and sunset on the horizon for your globe. So here's an example. This is fake data, so please don't use this. The sunrise equals 30 degrees, sunset equals 320, and the altitude of the noontime sun equals 80. So the sunrise and the sunset are positions on the horizon where you're going to see the sun come up and the sun come down. The altitude of the noontime sun is a measurement above the horizon. It's basically telling you how high up in the sky the sun is going to be that day. So the first step is going to be draw the meridian. The meridian is this north-south line that runs directly over your globe, and this will be the position of your noontime sun. Step number 2, we're going to label the sunrise position on the globe. So I have a sunrise of 30 degrees on the horizon. Well, if this piece of paper right here represents my horizon, I want to put a dot on 30 degrees on that basically the bottom of this globe where the horizon is. So I know north is 0 degrees. The protractor I know says 90. However, this is only because I can read the side of the protractor. So I'm just going to simply count up 30 degrees. If north is 0, I'm going to go 10, 20, 30 degrees, and I'm going to put my dot right there to represent my sunrise position. The next thing I'm going to do is label the sunset position. So I'm going to go over here to the other side. I know that my sunset is at 320 degrees. And I'm going to use the fact that north is 360 to count down to 320. So it's 360, 350, 340, 330, and 320 degrees is right here. And I put a dot right on my globe to represent my sunset position. The next thing I'm going to do, step 5, is label the altitude of the noontime sun. Well, in order to do that, I'm again going to take advantage of the fact that I know that this piece of paper is the horizon. And if this is the horizon, I'm going to label 80 degrees above the horizon to indicate my position of the noontime sun, and I'm going to put a dot right there. The final thing I'm going to do with this is I'm going to draw a smooth line that connects the 2 points that is for sunrise and sunset and goes directly through the altitude of the noontime sun. So that on this particular day of the year, I see the sun come up over here on the horizon, get up to an altitude of 80 degrees, and set over here on this horizon. Now, the final thing you're going to do is you're going to label this line with the corresponding date. I simply put here Path of the Sun just to kind of let you know what that is. But for example, if this was July 31st, you would put that date right here. You're going to, without erasing the first line, repeat this process for the rest of the dates given. And then you're going to take a picture and you're going to insert it into your lab. One final note. Remember that the noon sun is always in the south. This is my south direction right here. North direction being up here. Do not put your altitude of the sun up here, all right? We can always see it in the south in New York State.